What could be outside of our universe? It's one of the most mind-boggling questions in science. For centuries, we humans have gazed at the skies and wondered if our universe, all the stars, galaxies, and space that we know, is where existence ends, or if there's something beyond. In this video, we'll explore the top 7 theories about what, if anything, lies outside our universe. Strap in for a trip past the cosmic horizon. We aren't going to dive too deep into any complicated math or heavy philosophy. Just try to give a clear and light-hearted tour of each theory. By the end, you can decide which idea blows your mind the most. Let's get started with the simplest, yet in some ways most difficult idea of all, nothingness. The first theory is straightforward. Nothing exists outside of our universe. By definition, the universe means everything that exists. So asking what's outside it might be asking like what's north of the North Pole. It just doesn't apply. According to this view, space and time themselves are confined to our universe. If our universe is finite in size, say, it curves back on itself like the surface of a sphere, it still doesn't require an outside environment. Think of a donut. You could travel in one direction and eventually end up back where you started, without ever finding an edge or external space. In other words, even a finite universe can be self-contained with no beyond. This concept is truly mind-bending because we're used to imagining objects inside space. But if the universe is the ultimate container of all things, there is no container outside of it. Nothingness means nothing. Not even an empty void or a dark space. There's simply no outside at all. It's a tough idea to wrap our heads around, but it could very well be the truth. Our next theory changes the question slightly. Instead of outside the entire universe, it considers outside the observable universe. The observable universe is the region of space we can see, about 93 billion light-years across, limited by how far light has traveled since the Big Bang. But there's no reason to believe space suddenly ends at that boundary. Most cosmologists think the universe extends far beyond what we can observe, and it could even truly be infinite. If that's the case, then outside our visible universe, there's just more universe, more galaxies, more stars, possibly going on forever. In an infinite universe, things get weird and exciting. With an infinite expanse, every possible arrangement of matter could exist somewhere. Given enough space, eventually you'd find repetitions, regions of the universe that look identical to ours, even doppelgangers of Earth and of you, simply because infinity allows every configuration of atoms to occur. This isn't science fiction. It's consequence of infinite space with a finite number of ways to arrange matter. So beyond our cosmic horizon might be other galaxy clusters, and farther still, maybe an Earth indistinguishable from ours. In this scenario, there's no separate outside, just an endless stretch of space continuing on and on. Keep in mind, we don't know if the universe is infinite. It could just be extremely large yet finite. But current observations show space is very flat and uniform on large scales, consistent with being infinite or at least so huge that it might as well be. If true, then what lies beyond our sight is simply more cosmos. No exotic new realms or separate universes, just a vast extension of the same universe that we live in, potentially containing familiar patterns, far beyond our reach. Now let's step into some more speculative territory, the multiverse. One popular multiverse idea is that our universe is just one bubble in a frothy sea of bubble universes. This comes from cosmic inflation theory. Inflation is the idea that our universe underwent a tremendous rapid expansion right after the Big Bang. According to some models, inflation might not happen uniformly everywhere. Instead, it could stop in some regions, which create bubbles that become individual universes like ours, while continuing in others. The result is an ever-expanding backdrop with countless bubble universes popping into existence. Our universe could be a swelling bubble that formed in a larger multiverse, and outside it, other bubble universes float around in an eternally expanding cosmic foam. In this bubble multiverse scenario, each universe could have its own distinct laws of physics or fundamental constants. One bubble could have heavier gravity, another might have different particles, some might not even allow stars or life, while others could be somewhat similar to ours. We'd never be able to travel to these universes because they're separated from us by regions of space that are still inflating, and possibly by physics that we can't penetrate. However, there is a chance that bubble universes could collide or influence each other. Researchers have even searched our sky for hints of past bubble collisions, so far without conclusive results. Another theory takes us into the realm of extra dimensions and string theory. In everyday life, we experience 3 dimensions of space plus time as a 4th dimension. Some advanced physics theories that we don't have time for today suggest that there are additional spatial dimensions beyond these 4. In effect, what we think of as the entire universe might just be one slice of a bigger, higher dimensional reality. If this idea is about reality is true, then outside our universe isn't a faraway region of normal space, it's literally a direction in a higher dimension. Imagine our 3D universe is like a flat sheet within a 4D volume. Another universe could be a parallel sheet separated from ours by a small distance in the 4th dimension that we can't directly sense. These other universes could be quite close to us in the bulk, maybe only a few millimeters away in that extra dimension, and we'd never know because we can't penetrate that higher dimension. However, physicists theorize that our gravity or other forces might be able to reach across the extra dimensions. Scientists have looked for hints of extra dimensions in particle experiments and cosmological observations, but nothing definitive has turned up yet. Still, if this theory is correct, what lies outside our universe could be an entire higher dimensional space that we're physically incapable of experiencing except through subtle effects. Now, not all ideas of other universes involve traveling through space or extra dimensions. The many worlds interpretation of quantum mechanics proposes that other universes exist as parallel branches that split off from our own reality. In quantum physics, particles can exist in multiple states or locations at once, a superposition, until they interact or are observed. According to many worlds theory, whenever a quantum event has multiple outcomes, all outcomes actually occur, each in a different branch of reality. So the universe splits into parallel versions, one for each outcome. This means that there could be a near infinite number of parallel universes overlapping with our own, but we can't see them because they exist in a kind of quantum superposition with ours rather than being separated by distance. As wild as it sounds, the many worlds idea is a serious interpretation supported by some physicists. It holds that there are many worlds which exist in parallel, at the same space and time as our own, containing alternate histories of our universe, even one where your Powerball ticket won. In one of these parallel universes, you could have chosen a different career, or maybe dinosaurs still roam Earth. Anything that could have happened did happen in some branch. These aren't universes you could travel to, they're entangled with ours, not sitting in another part of space. So in this view, asking what's outside our universe isn't quite the right direction. Instead, all possible universes coexist with ours on a quantum level. It's important to note that this is an interpretation of quantum mechanics, and it remains controversial. Still, it's a commonly discussed theory in the context of multiverses. Consider this. What if our universe is actually the inside of a black hole? It sounds wild, but new results from the James Webb Space Telescope have breathed life into this idea. When the telescope looked deep into cosmic history, found something unexpected, a strange imbalance in the way distant galaxies are spinning. Instead of an even mix of clockwise and counterclockwise like expected, more galaxies spin in the same direction. That kind of cosmic alignment shouldn't happen if spins were completely random, but it would make sense if our universe was born with a built-in rotation. This is where black hole cosmology comes in. Physicist Nikodem Poplawski and others have suggested that when a massive, rotating black hole forms in some larger, parent universe, it could trigger the birth of a new universe inside. The newborn cosmos would inherit the spin of its parent black hole, leaving a preferred direction imprinted on the galaxy from the very start. James Webb's discovery of galaxy spin bias is exactly the kind of evidence this theory predicts, a universe that carries a cosmic twist in its DNA. Now, it's important to be cautious. These findings don't prove that we live inside of a black hole. The spin imbalance might turn out to be observational bias or other factors that we don't yet understand. Still, the fact that the James Webb Telescope's data lines up with predictions from this theory is exciting. If true, every black hole could be a seed for a new universe, and our cosmos might itself be the child of one. Whether or not this turns out to be correct, the idea pushes us to think bigger. It suggests that outside our universe could be a larger parent cosmos, with black holes acting as gateways between realities. And thanks to the James Webb Telescope, what once seemed like pure speculation is starting to look just a little more plausible. Our final theory comes not from cosmology, but from the realms of philosophy and technology. It's the idea that our universe might be an artificial simulation. If that's the case, then outside our universe would be the real world that's running the simulation. This concept was popularized by philosopher Nick Bostrom's simulation argument. It suggests that if advanced civilizations gain the ability to create extremely detailed simulations, think of a universe-scale video game or computer program with conscious beings in them, there might be vastly more simulated worlds than there are real ones. Therefore, it is plausible that we are living in such a simulation. In simple terms, everything that we perceive, matter, energy, space, time, our laws of physics, would be part of a computer-like construct. The simulation hypothesis posits that what we experience as reality is actually a simulated reality, perhaps run on advanced hardware by beings in another universe. If this is true, then asking what's outside of our universe is akin to asking what's outside the simulation we're in. The answer would be the higher-level reality where the simulators exist. Tech luminaries and scientists have debated it seriously in recent years. They argue about whether certain physical limitations, like the speed of light or quantum behavior, could be signs of a programmed universe. It's a popular idea in culture, and unfortunately, we would have no way of knowing if we're in a simulation or not. Maybe one day, we'll wake up on the outside. From nothing at all, to infinite expanses, to bubbling multiverses, higher dimensions, quantum branches, black hole parent universes, and even computer simulations, we've journeyed through a lot of mind-bending possibilities. What lies outside our universe? We still don't know, and likely we never will. Our current science can't really peek outside the universe we inhabit. All we can do is infer and imagine based on what we do know. Each theory we discussed has its appeal and challenges. And it's important to remember that these are all hypotheses. There's no experimental confirmation of other universes or an outside yet. But thinking about these big questions isn't pointless. It pushes the boundaries of science and keeps us curious. As the saying goes, the absence of evidence is not evidence of absence. Either way, the ideas we explored show just how wondrous the conversation about our universe can be. Whether we live in a lone universe or a multiverse teeming with other worlds, the quest to understand the cosmic beyond teaches us a lot about our own universe and ourselves. Stay curious, keep looking up and out, and thanks for watching.